This is Abhishek here,
I am Anantramar.
and this is our friend Abot. And let's get started. So, our project name is Pick and Place. Our as I've already explained, the name of the project is Pick and Place. It's done by the four of us. Two of us, Pranav Kumar and Nikita, are unable to join us because they are out of town. Yeah, so they are not able to attend the shoot. And our project mentor is Girinathar. So we take a moment to thank him for the help that he has done for this project. So the aim of the project is to design a pick and place bot using ESP32. So we're going to tell you a story from where we started to where we are here. I showed you a bot, right? So we're going to show you the story of how we are here. So we got started with assembling two DC, a basic chassis kit with two DC motors, two wheels basically. So a motor driver L298N or the H bridge motor driver was attached to control the wheels. This was connected to the ESP32 board. A caster wheel. This is the caster wheel. One second. Yeah. So this is the caster wheel. So caster wheel was added in the front to support the bot. So this is something that we tried extra. We also tried a couple of encoders, an optical encoder as well as a magnetic encoder. We tried. This is not part of the project. So I'll show you the optical encoder in a particular video in a later slide. So yeah. So this is what I'm going to show you. The demo that I'm going to show you is to make the bot move from here to, let's say, here. So this is the movement that it's going to make. Let me show that. Uh, this is the code. So the connections and stuff I'll explain later. So yeah, it basically goes in front 4 units and goes to the right 4 units. That's all. How does the code work? I'll explain in the next slide. How it works. Yeah, and so after the testing of the three-wheel bot, we moved on to this code called website code. So we just wrote a code where we can give the user the option to move forward. These are the connections that have been made, the pins, respective pins. All of this has been summarized in a later page. So we'll be talking about this again. So yeah, so this is the HTML page that will be rendered on your screen, and a screenshot of this page is also going to be attached in the next few slides. So this is the okay, and this is what is going to happen when when we want to move forward, backward, right, or left. So that's been mentioned here. So again, this is going to come again in the next few slides. So this is just to give you an idea of how the code looks like. So over to Anand, who will be taking over from the next page.
So from the two-wheel bot, we then move on to the four-wheel bot with four DC motors, two motor drivers, the L298 and motor drivers, which was again connected to the ESP32 board. This was controlled using the website code that I had shown. In the next page, I'll be explaining the connections. So these are the required connections for the motor driver. We use six the GPIO pins, the general purpose input output pins of the ESP board. The in1, in2, in3, in4, enable A and enable B are connected as mentioned. And for moving the bot, we give the inputs corresponding to whatever we want to do. For example, let's say we need to move forward. The inputs 2 and 4 will be high, and input 1 and 3 will be low, and it's the opposite for moving backward. For moving right, we'll give input 2 as high, and for left, input 4 will be high. A modification can be done in this. For moving right, we can make the right wheel move forward and the left wheel move backward at the same time. This makes sure that the bot uh, gives a complete 90-degree turn on the spot instead of moving in a diagonal way. The Abhishek will be demonstrating.
So if you move only the right wheel, it will move like this. It's like a normal right turn that we make in normal cars, right? So this is a normal just right getting on. So if you are going to make the right wheel go forward and left wheel backward, then it won't make a right turn, it will rotate rightwards, so it will move like this. So that's the difference. So how it looks, I just wanted to give an idea.
So this, as in this page, you can see the interface for the website, and this is the message we get when the Wi-Fi gets successfully connected to the ESP32 board. So now Abhishek will be giving a brief intro about the ARM.
So yeah, I want to go fast through this. So we all of us are actually new to all of this. We've never handled DC motors before. We've never handled servos before. We don't know what are the types of joints that are there, what are the number of degrees of freedom that are there. So everything we've learned new. So that's the main point here. So we learned about the different types of joints, and we chose to have 5 revolute joints, and those joints are the joints that have been mentioned: base, shoulder, waist, elbow, and wrist rotation, pitch, and roll. So there are 6 servos actually. So 5 servos that indicate the 5 degrees of freedom, and one extra one for the gripper. The gripper is the one that catches hold of the object. So yeah. So this is how the final design works. I've already told you 3 MG996 servos or mega servos, and 3 SG90 servos, micro servos have been used for the wrist roll, wrist pitch, and the gripper joints. Waist, shoulder, and elbow are the mega servos, and the plastic parts that have been shown, the blue parts that are those parts were 3D printed in the CED Makers Lab that's available in our college. So after it's 3D printed, we made the following connections as shown in the figure, and it's just giving power supply for these all the servos, and each one of them have been connected to one pin of the Arduino board as shown there, and it has been run. So those are the connections that were made. So the connections that have been made, I've already shown you. So this is just a code that we wrote to make sure that all the servos are working. So we've attached all the servos to the respective pins. And what we've done is, so we're just making making each servo to move from 0 degree to 180 degree, with each joint separated by a delay of 1 second. So that is what we are doing. First, the waist will move from 0 to 180 degree and back to 0 and stop, and then the next one, and then the elbow, and then the shoulder, etc., till the gripper. So that's the thing. So basically, it's just to make sure all the servos are working. Nothing else. So let's have a look at how it shows up in real life. So the base is rotating. You can see one after the other, the joints will rotate. So you see that each of the joints goes to the maximum and then comes back to the initial position, just to check the working of the servos. Code. So that was to just to test. So this one has a way of taking input. I'll show you that. So yeah, so this is how it works. So basically, it takes input at the serial monitor. There is a place where you can give input. There we give input as $101 let's say, for example. So what happens is, this code extracts the string, takes integer by integer. The first integer marks the waist, from the second one the elbow, and so on till the gripper. So the six numbers will indicate this particular servo to either go to 180-degree or to stay at 0 degree. So that's how this code works. So this was the second intermediate code that we used to check our bot. And the final code that was that we implemented for the robotic arm will be explained by Anand.
So this was the final code that we decided to use, which included a Bluetooth module and an app to control the movement of the bot. Here we can see the circuit connections. It's a very simple connection. We just give the power supply and connect the Bluetooth module also to the Arduino board. So now I'll be showing the code. This is the interface of the app, which I can show you when we meet in real life, and this an example of how it works.
So we finally come to the final stage of the project. So we're just going to take a look at how the final look of our bot looks like. I know some of your eyes would have gone to that one jumper wire that's hanging in the air. Sorry about that, but that's how the bot is looking like now.
So this is the final working of our bot. So yeah, that was the pick and place being performed by our bot. This was what we learned from the project. As Abhishek had mentioned earlier, we had absolutely no clue about what we are going to do, what DC motors are, what servo motors are, the H bridge motor drivers. So it was a very good learning experience for all of us. We learned how to integrate all these parts, the motors, and how to work with ESP32 board. We have also tried to innovate uh, as much as possible. For example, what he said before about the optical encoder for measuring the distance and stuff like that. And then we designed a model using a 3D printer, which was a very new experience for us. We have never seen a 3D printer before, so that was very enjoyable. We then learned all about the arm, the joints, servos, the degrees of freedoms, and so on.
So now to the tough part of it, the demerits and the possible upgrades. So, but the important part of it. So the demerits of the project that we can see, not enough power for the mega servos and micro servos were actually there. So that was the reason many times it was not working as it was supposed to be. So if we use a buck converter, that is a step down converter, possibly instead of 5 volt, if we go with 9 volt as input and step it down to 4.5 volts or 5 volts, at the same time we know that current is going to be it is going to get twice, right? So we need more current. That is the problem. So the 5 volt is the requirement, 5 volt is going, but in parallel we have 6 servos here, so that's the problem. So current is getting reduced a lot, and the micro servos are working perfectly, but the mega servos are creating some problem. So for that, perhaps a buck converter's usage would have made it much better, and we can make the robotic thing much more stable and rigid. It's a little haphazard. Perhaps it's because of SPK, because he's gone to Singapore. The both of us are probably a little bad at making rigid final things, and then weight of the arm makes the bot slow. Yeah, obviously. Size of the arm can be made smaller, and we can reduce the number of microcontrollers because we ran out of points in the first one, so we had to go to the second one. So we can see if we can reduce the number of points somehow and reduce the number of microcontrollers to reduce the cost. So those are the possible demerits and upgrades. So hence we picked and placed. And thank you so much for patiently listening with us. And bye.